452b 452b 452 Mesa 2015 G2 452 60% 2.0 452b 1 2015723 NASA 452b 452b 385 2 452 452b 1 452b 60% 2 452b 452b 6452b 3 452b 1 452b 452b 2 452b 3 2026 Plateau 452b 1 NASA 2015 NASA's Kepler mission discovers bigger, older cousin to Earth. 2. The Open University 2025. Curious kids, could humans live on Kepler-452b? 3. Space.com 2015. Kepler-452b, what it would be like to live on Earth's cousin. 452b. Counterintuitive information regarding Kepler-452b. 1. Potential for life versus environmental conditions. It may seem intuitive to assume that a planet located in the habitable zone of a star similar to our Sun would be suitable for life. However, despite Kepler-452b's position in this zone, the planet's high mass and gravitational pull approximately twice that of Earth's could create an environment that is detrimental to human life. The increased gravity may lead to physical adaptations that could make long-term habitation challenging, contrary to the hopeful assumption that being in the habitable zone is enough for life to thrive. 2. Older star, not necessarily more stable conditions. Kepler-452's host star is 6 billion years old, which, while similar to the Sun, indicates that it is in a later stage of stellar evolution. A common assumption might be that older stars provide stable conditions for longer periods. However, as stars age, their luminosity increases significantly. This increased energy output could lead to conditions akin to a runaway greenhouse effect, as seen on Venus, which could evaporate any existing surface water and render the planet inhospitable, contradicting the notion that age equals habitability. 3. Super-Earths and habitability. Kepler-452b is categorized as a super-Earth, larger than our planet. The assumption might be that larger planets are more likely to support life due to their size and potential for geological activity. However, the increased mass can lead to higher gravity, which could complicate biological processes. For example, the adaptation required for life forms to thrive under higher gravity could lead to completely different evolutionary paths, making the planet less familiar and potentially less hospitable for Earth-like life. For human adaptation misconceptions, it is suggested that humans could adapt to Kepler-452b's higher gravity, potentially becoming stockier over generations. This implies a straightforward path to adaptation. However, the biological limitations of humans, particularly in terms of reproductive health and long-term physical changes, could make such adaptations unlikely or problematic. Thus, the optimistic view of human adaptability does not fully account for the complexities and potential difficulties of evolution under different gravitational forces. 5. Atmospheric assumptions. There is an expectation that a planet like Kepler-452b, if it supports life, would have a breathable atmosphere similar to Earth's. However, the exact composition of Kepler-452b's atmosphere remains unknown, and it's highly likely that it differs significantly from Earth's. This uncertainty complicates the assumption that colonization would be possible without significant technological intervention to provide suitable living conditions. 6. Liquid water and its longevity. While Kepler-452b is located in the habitable zone where liquid water could exist, the planet may not have stable bodies of water for long durations. The increased stellar brightness and energy output could lead to the evaporation of any surface water over time. The assumption that being in the habitable zone guarantees the presence of liquid water fails to consider the dynamic and changing conditions that could lead to its loss. 7. Misinterpretation of Earth-like. The term Earth-like is often used to describe Kepler-452b due to its size and location. However, this characterization can be misleading, as it may lead to the expectation that conditions on Kepler-452b would mirror those on Earth. In reality, the differences in gravity, atmospheric composition, and potential geological activity could create an environment that is vastly different, and possibly hostile, to human life. 8. Future exploration and optimism bias. There is optimism surrounding future missions like the European Space Agency's Plato spacecraft, which aims to discover more Earth-like planets. This may lead to the belief that finding another Earth is imminent. However, the challenges of identifying truly habitable conditions are immense, and the assumption that similar planets will have similar conditions can result in an overestimation of the likelihood of finding a suitable second home for humanity. In conclusion, while Kepler-452b is often referred to as a cousin or twin of Earth, the realities of its environment challenge many intuitive assumptions about habitability. The complexities of planetary science and biology suggest a much more nuanced understanding of what it means for a planet to be capable of supporting human life. Kepler-452b 452b 2015723 NASA 452bg 2452 452b 60%. 385 1 452b 452b 6 2 452b 3 452b 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 1 452b 2 452b 3 2026 Plato 452b 1 452b 45260 2 3 452b Plato 452b 452b 1. Discovery and confirmation of Kepler-452b. The discovery of Kepler-452b represents a significant milestone in the search for potentially habitable exoplanets. On July 23, 2015, NASA announced the confirmation of this planet, which orbits within the habitable zone of a star similar to our Sun, known as Kepler-452. This region is crucial as it allows for the possibility of liquid water, a fundamental ingredient for life as we know it. The planet is approximately 60% larger than Earth and is classified as a super-Earth. The fact that it has a nearly Earth-like orbit of 385 days further raises hopes about its potential to support life. The discovery process involved rigorous data analysis from the Kepler mission, showcasing advancements in technology and methodologies used in exoplanet detection. 2. Planetary characteristics and environmental conditions. Kepler-452b exhibits several intriguing characteristics that make it a subject of interest for astrobiologists. It has an estimated mass 5 times that of Earth, resulting in a gravitational pull approximately twice as strong. This increase in gravity would have profound implications for any potential life forms or human colonization, as it would impact mobility and physiological adaptation over time. Additionally, the planet's surface might feature active volcanoes and a thick atmosphere, though the exact atmospheric composition remains unknown. These factors create uncertainty regarding habitability, as the atmosphere may not provide the necessary conditions for human life, such as breathable air in suitable temperature ranges. 3. The future of Kepler-452b and potential for human habitation. Despite its promising characteristics, the future of Kepler-452b is subject to significant challenges. As its host star ages, it is 6 billion years old, compared to the Sun's 4.5 billion years, it becomes brighter and hotter, potentially leading to a runaway greenhouse effect akin to what occurred on Venus. This scenario could result in the evaporation of surface water, making the planet inhospitable. Scientists speculate that within the next 500 million years, Kepler-452b may face significant environmental changes that could eliminate its ability to support life as we understand it. Ongoing and future missions, such as the European Space Agency's Plato satellite scheduled for launch in 2026, aim to gather more data on Kepler-452b and other Earth-like exoplanets, providing insights into their atmospheres and potential habitability. 4. Implications for Earth and broader astrobiological considerations. The study of Kepler-452b not only informs the search for extraterrestrial life but also offers a reflective lens on Earth's own environmental challenges. As humans explore the cosmos for new homes, the conditions on Kepler-452b serve as a reminder of the delicate balance required to sustain life. The potential for life on other planets prompts critical discussions about ecological stewardship on Earth, given our planet's vulnerabilities to climate change and environmental degradation. Understanding the evolutionary trajectory of planets like Kepler-452b can illuminate the future of life on Earth and the broader universe, influencing both scientific exploration and public policy regarding our planet's preservation. 1. Mars exploration and colonization efforts. Mars has long been a focal point for discussions about potential human colonization due to its relative proximity and similarities to Earth. NASA's Mars missions have provided extensive data about the planet's surface, atmosphere, and potential for water. The ongoing exploration, including rovers like Perseverance, aims to assess the feasibility of sustaining human life. Just like discussions surrounding Kepler-452b, scientists speculate on the challenges of higher gravity, atmospheric composition, and the long-term effects of living on Mars. 2. The search for exoplanets, Proxima Centauri b. Proxima Centauri b, discovered in 2016, is another exoplanet located within the habitable zone of its star, Proxima Centauri, the closest star to the Sun. It has garnered attention for its potential to host life. Researchers analyze its size, distance from its star, and surface conditions to determine if it could support liquid water. Similar to Kepler-452b, there are significant uncertainties regarding its atmosphere and the impact of the star's radiation on potential life forms. 3. Theories of life on Venus. Venus, often referred to as Earth's sister planet, has been a subject of interest regarding the possibility of life. Though its surface conditions are extreme, some scientists have hypothesized that microbial life could exist in the more temperate upper atmosphere. The exploration of Venus, including missions like NASA's upcoming Da Vinci Plus, aims to understand its atmosphere and geological history. This parallels the exploration of Kepler-452b in that both planets present challenges and opportunities for understanding the potential for life in hostile environments. 452b 452b 2015 452b 1 452b Mesa 1, 400 452b 1.6 2 452b 6452b 3 452b 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 4 2026 Plateau 452b 5 452b 452b